Hello, let's solve pips. We're going to place some dominoes. We've got one from Ian, two by Rodolfo. Let's start solving the easy puzzle. Okay, we need 4 of something. It looks like that will be 4s, actually. So we need a double 4 up here. We need 2 of something, which looks like maybe 0s or 1s. What about our other 4s? We need... one of them will go here. Yeah, it'll be this one, actually, because we can't make the 9 in a single domino, which means we need the 4 pointing into it. So the 6 goes into the 9. We now need the 3, finishing that off. This needs to be greater than 4, so we need a 5 to compensate for that 0, and the other 1 finishes the equivalence region, and there we go. That was the easy puzzle. Let's try the medium. Okay. We need a 1 over here. There's only 1, so that's fine. We need equivalence here, which is going to be 3s or 0s. In theory, it could be either of those. Oh, and then the other of them will be in the other equivalence region, I guess. But they both do have doubles. So so we need the less than 5 connecting to something that isn't 6. I mean, that's not very difficult currently. Well, actually, if we're not able to use the 0s or 3s, then it's a little bit more constrained. Because it can't be this 2, 6. It can't be this 0, 6. So I think it might have to be this 4, 5. That's interesting. So now the inequivalence region can be neither 6 nor 5. It can be neither 3 nor 0. So it's just 2, I think. And it has to go here because the 6 isn't the thing of which we have 3. So now we have less than 2. No, this doesn't make sense. Oh no, we have 4 zeros. It does work. Sorry. Yeah. Okay. I was thinking we don't have enough zeros to make this work, but we do. We put 2. No, this doesn't work. Right. I sort of messed this up because I didn't realize we had extra zeros. So I think I was thinking about this incorrectly. It might be the case that the inequivalence region is a double 0 here because I just miscounted those. Although, no, that doesn't work either. Never mind. Maybe this is the 6s up here. Sorry. And then... no, this doesn't work either. What if it goes this... Okay, sorry, I'm messing this all up. No, see, yeah, I'm messing this all up. Does this work? No. I might have to start this over because I think my miscounting, I think, has led me into just a situation where I don't know what's going on. Sorry about that. That's my big hazard on this game. So this would have to be double 3. Oh no, this works. Okay, good. I corrected my tailspin there. Okay, sorry. I made one bad count, which is so common to miscount the zeros specifically. It's a thing I seem to do all the time. So that little mistake caused me to just make some other bad assumptions, but fortunately we caught back up. Okay, we'll move on to the hard. Here we go. It's a D. It's a letter D. Okay, so we need a 5 pointing into something of which we have 4. That might be a good place to start. It could be 5, 1. We do have 4 1s at least. Could it be 0? We do have 4 zeros. Although, yeah, we don't need to double. You know, if we put the 5, 0 here, we don't need to double 0 for that to work. We have a 5, 2. Yeah, we have plenty of 2s. Okay, that's not the place to start at this point, I don't think. What about this 4, 5? Do we have a 4, 5? Because if we don't, then that will start telling us some orientations. And it looks like we don't. Don't think we do. So that means, you know, we can't connect the 4 and 5, which means the 4 connects to this equivalence region. So we need a 5 that connects to this equivalence region and a 4 that connects to this equivalence region. So let's try this again. If we had 5, 2, for instance, do we have a 4, 2? It looks like we don't. Yeah, so this is a good place to start, perhaps. So that 5, 2 didn't work. What about 5, 0? I think this will work in theory. So we do have a 4, 0 here. Are there any other good possibilities? We've got a 5, 1, but I don't think we have a 4, 1. No, I think that might be the only one that works. I think we only have these 3, 5 options, and this is the only one that works. So I think that's correct. So that's good. So so these are zeros as well. And we also have greater than 15. Greater than 15. So that could be 2 5s and a 6, 2 6s and a 5, 3 6s, or 2 6s and a 4. We do have 3 6s, so we have quite a lot of leeway in terms of that one. There's also this 5 up here, which we only have 2 5s left now. So 5 connecting to greater than 2, or 5 going into an inequivalence region. It's 5, sorry, to the equivalence region. It's 5 going into the equivalence region because we don't have a 5 connected to a greater than 2. So this 5 connects to a 2 or a 1, and we have plenty of 2s and 1s. So that in and of itself is not necessarily very useful. This equivalence region up here, because of what we've determined with this 4, 0, we will need a double in the top of this inequivalence region. I mean, we would have needed a double one way or the other, but in this case, we need one in the top bar there. So that will be double 4, or double 1, or double 2. Okay, we've got plenty of possibilities. Do we have enough to manage all of those? Actually, we don't have enough double 4s for that, do we? Sorry, we don't have enough 4s is what I mean. We don't have a third 4, so actually that's out. So it's 1s or 2s, and we do have enough of each of those. Speaking of 4s, we'll need to use this double 4 here somewhere. Now, obviously, it can't point up, so it's either across or it's down into the inequivalence region. If it's down, oh, right, and all of our 5s are spoken for as well. I mean, the problem is, either of these 5s is fine in theory because we just need to put a thing that isn't 4 or 2 in there if that's the case, or isn't 5 and 1 in there if that's the case. This isn't hugely useful. Although, actually, sorry, our 15 is going to slightly cut down our options in that general area. What about zeros pointing up? We will need a 0 pointing up into the greater than 15. Sorry, I should have started looking at that after I placed these, because it has to be this 6, I guess. Right? I'm not missing another 0, am I? Yeah, that must be right, because obviously 0, 2 isn't enough to be in a greater than 15 region, so the 0, 2 does go there. So now we need... I don't think we can do this in a single domino, because we'd need something equal to greater than 9. Not 9 or greater, but greater than 9. And we don't have that. So we need 4s, 5s, or 6s pointing up. And if it's a 4 pointing up, we need another 6. But that is doable. That is doable. So what points up into the... Well, what points up into the greater than 2, and what points up into the equivalence region? Also, this 5 points into the equivalence region. It needs to now. So it is 2s or 1s. Okay, so this will be fairly constrained. Let's just say, because there are only 2 possibilities for that. Let's just see if this works. So if it were 5, 2, we'd have a 2 pointing down, which we could do, because we could do 2, 6, and that's fine. And then all we need is a 4 pointing up here, which we could do with this 4, so that's fine. Let's just look at the other possibility to see if it equally works. We would have a 5, 1 here. We would need a 1 pointing down. This doesn't work. This immediately breaks. We don't have a big enough 1 connection. Okay, good. So that's good. So it's the 5, 2. The 2 points down with a 6. Oops. And then we need 4, 5, or 6 pointing up. And that could be either this 6, 3 or this double 4. We don't know which yet, but that was still helpful. So now we need a double over here. And this could be a double 4 or... No, it couldn't be a double 4. We've already determined that. It's a double 1 or a double 2. Do we still... we still have enough to make that work in either direction, unfortunately. This 5, 1... We now know it's a 5, 1. I mean, that removes a 1, but that still doesn't do anything, because we could still have 1, 1, and then 1, 2. Would that work if we did that? Greater than 2 connected to this, that would work. Maybe it is this. And then double 4 would have to go down. Yeah, this does work. And then double 2 finishes the inequivalence, and there it is. Okay. Well, there we go. That was the hard. So a little bit of back and forth on that one, but we got there. And those were the pips. Back tomorrow. Bye for now.